Okay, this is Mentor Robot episode 5. I've done some work on the wrist, and what I've done here, I've put a grub screw in this square block here, and this bevel gear next to it runs freely, so this block is effectively fixed to the shaft going through here. So when this motor moves, this will go up and down. That's just bend. Because this is moving freely, it'll just run round, and swivel is the other axis. So that's what I've done there, and I've written some code, changed the code around quite a bit. I'm playing with a new bit of code, and we're now running with total coincidence. Before, there were time delays for each move of the robot, and they were just 4 next loops basically. So the robot would move to a position, wait for the timer to time down, then move to the next position, and so on. What I'm doing now is I'm running true total coincidence. So looking at this screen, for this particular axis, that's the pot value that's coming back, and this is a tolerance value to make sure that it's within tolerance. Now I've got the tolerance set quite high at the moment. I think the tolerance is 25, so it could be 25 bits out, and that's because I just still haven't got around to calibrating the robot properly at the moment. It's a real pain in the backside to do, but if I just list, I can't do this one-handed. Let's list that program. 10 300. There we go. So what I've done here, I've set a tolerance is 25, and then we've got minimum and maximum values for each axis, and the midpoint I could have just set that as one value actually, but I just put them all in. So axis 5, which is the gripper actually, which isn't running at the moment, but axis 4, which I think is bend, axis 3 is swivel, axis 2 is the elbow, axis 1 is the arm up and down, axis 0 is the waist. So we've got some values there. Let's just list a bit more. There's a proper way of doing this on the BBC, and I can't for the life of me remember what it is. But if I do that, next part of the program, what we're doing here now, we're going to a place called Do Ready, and Do Ready is the arm pointing up in the air, which it should look more or less like that. You'll see that because it's not calibrated properly, it won't quite get to Do Ready, but it's close enough at the moment. So that's where it should go to. From the Do Ready position, we then run each individual axis. So we run it from its minimum point to its maximum point, and then back to the midpoint, which is back to Do Ready, and we do that for every axis. So that's the waist. Here I've done axes 1 and 2 together because I'll hit the shelf otherwise. I haven't got enough space, so that runs axes 1 and 2 together. And what it actually does here, there's an array called axis pos, and it's the axis and the position. So all I'm actually interested here is, this is saying, I know this is axis 0, but axis 0 and what its position is, and it's equal to its minimum value. Axis pos is equal to its maximum, and so on. But here what it'll do then, it'll call a procedure called MoveBot, and all that does is it gets those values, puts those onto the correct address, moves the robot, and then it'll call a procedure called check TC, check total coincidence, and if I just list this, there we go. I think it's right down the bottom here. There's a procedure here called check total coincidence. It'll repeat round, and what it does is it goes away and reads the ADC here, and then it creates what that actual figure is coming back, and it puts it in here. And this here says it'll take the absolute value of that pot value that's coming back on the particular axis, and it takes it away from where I told it to go. So, and it creates that as an absolute value, so whether it's negative or positive, it'll always be positive. So this value should, in here, should come back with a value that is where I told it to go against where it actually is, and that will come back as a value in here. I've just put some print tabs here to show what the values are, but it'll do that until a particular pot value is less than or equal to tolerance. So that's axis 0, axis 1, axis 2, 3, 4, 5, and so on. So it will keep going round until it's reached coincidence. So this will just keep running round and round and round and round until we reach coincidence. Once we've reached coincidence, it'll drop out of the procedure, drop back into the program, go on to the next step. So that's how it runs. So let's see what it does. Okay, we can run that. Switch it on. So the first thing it does each individual axis. So this is axis 0, going from minimum to maximum, and then it should go back to the midpoint. The reason I've done this is because obviously it'll hit the shelf. But you'll notice now that there's no pause in its movement. It's tracking total coincidence. So that's swivel moving independently of bend. That was a little mod that I did. And now you'll see bend move. There's bend. You can't get bend to move independently of swivel because the way that the bevel gears are. So now once it's done all the axes, it goes to a kind of a warm-up program. But you should see now that there's no delay on the steps. It's waiting to reach total coincidence each time. And I think we see that better when it comes round here in a moment and it waits. See, now it's waiting for that axis to catch up. And now it waits for swivel. So now each time it's reaching total coincidence as it goes round. So there's no time delays, there's no stops on the movement. So it gives a much better flow to the movement of the robot. So next thing to do is to get the gripper finally sorted, get the calibration right, and then I want to do a thing that back in Unimation days was called approach. So I can approach a particular point, say 100mm above it, and then the hardest challenge is one that's called move S, which is moving a straight line. So it will approach a point and move down to, if you were going to pick an object up, you want the gripper and the axes to all move together to maintain a straight line as it goes to pick that part up. That's definitely going to be a challenge. Okay, that's episode 5. Thanks for watching.